Welcome to Summarize Science, where we simplify the latest breakthroughs. Today we are exploring a manifesto called Agentic Microphysics, which changes how we think about AI safety. Traditionally, researchers test one AI model at a time to see if it behaves well. But as AIs start working together in groups, these single model tests are becoming obsolete. This paper argues that even if every AI in a group is friendly, the group as a whole can still do dangerous things. They call this the level of agentic microphysics, focusing on the tiny interactions between individual agents. Think of it like a crowd of people. A few simple interactions can lead to a sudden stampede even if no one intended it. The researchers suggest that we need to study how one AI's answer becomes the next AI's starting point. Table 1 in the paper breaks this down into levels, from a single agent up to a whole population. At the meso level, agents might form coalitions or polarize into opposing groups. To solve this, the authors introduce a methodology called Generative Safety. This involves growing potential risks in a laboratory setting to see what triggers them. Instead of waiting for a disaster, they want to simulate it first to find the breaking points. The paper lists 3 conditions for a good safety model. It must be descriptive, explanatory, and observational. This means the model should not only predict what happens, but also explain why it happened. One fascinating experiment mentioned involves AIs browsing a news feed. It turns out that AI agents are very sensitive to where an article is placed on their screen. Items at the very top were selected almost every time, regardless of how many likes they had. This creates a herding effect where the agents all focus on the same small set of information. This is a huge discovery because it shows that the design of the interface is a major safety variable. An attacker wouldn't even need to hack the AI. They could just manipulate the feed to control the group's attention. This suggests that ranking-based perturbations could induce synchronized shifts of attention across otherwise diverse agents. To prevent this, the paper outlines a 5-stage pipeline for identifying and stopping multi-agent risks. This includes formulating hypotheses and testing interventions like changing the memory or communication rules. To recap, the core message is that safety is no longer just about the code inside one AI. It is about the social dynamics and the environment where these AIs live and interact. In the future, this could mean that the way we build AI networks will be as regulated as the AIs themselves. We are moving toward a world where agentic ecosystems need their own set of safety protocols. This shift will help ensure that massive groups of AI assistants remain helpful rather than chaotic. By mastering the microphysics of these interactions, we can prevent macro-level failures. It is a bold new vision for keeping our increasingly automated world under control. Thank you for watching this summary of a new frontier in AI safety on Summarize Science.